I'm Bryce Ritter.
And I'm Camryn Joyner, and this is our presentation on Go. The topics we will be discussing today are the history, basic and special features, additional resources, the tutorial, and the medium program demonstration. Golang is a high-level programming language created and supported by Google. The primary goals behind its design were to improve productivity while still maintaining a large network of users for projects. It is syntactically similar to C, which makes it quite easy to learn for those who have experience with other object-oriented languages, like C++, Java, etc. C++ and Java are also commonly taught as first languages for university students, which makes Go an excellent language to learn after basics. Go was created at Google in 2007 by Robert Geismar, Rob Pike, and Ken Thompson. Geismar thought Google needed something better and simpler, and collected two of his colleagues who all mutually disliked C++. The language was primarily designed as a replacement for C++ and allowed its developers to work around the flaws. Go is best when used for networking and web development due to its design to enable developers to rapidly develop secure web applications. The point of Go is consolidation, not innovation. Since being officially released in 2009, Go's performance, capabilities, and most importantly their libraries have grown. Go did not have huge popularity when first released, but attracted a more niche audience, one who also thought like the creators of Go, ones that craved simplicity and were interested in web development. Go has managed to gain popularity over the years by expanding its libraries and tools. It is now ranked top 10 in popularity by the TOB index. The TOB index updates every month, and as of April, Go is ranked number 7 in popularity, in front of other popular languages like SQL, Ruby, and Rust. Go has gained 0.57% more popularity since March alone. And Go's biggest gain of popularity happened in 2006, as you can see in the chart below. According to the TOB index, it was TOB's Language of the Year in 2009 and 2016. Many large companies use Go, such as Google, Twitch, and Netflix. Uber also uses Go due to its ability to handle large traffic simultaneously, similar to other companies like Twitch and SoundCloud. It's all about concurrency, the program being able to handle multiple computations at once. Golang does this with great success. Go excels at this with mobile apps, allowing the apps to do some of their processing on cloud and across multiple servers. Go follows the imperative, functional, and concurrent paradigms. Imperative paradigms means the user must write out how they would like each step of the code to be executed, rather than stating a desired output and letting the compiler handle the steps. A functional paradigm allows the programmer to compose functions that can be applied throughout a program to manipulate data. Most languages are functional. Concurrent paradigms mean multiple computations can be executed simultaneously, which greatly improves performance and efficiency within a program. Also known as multi-threading, tasks are broken down into smaller executions called threads and can run all at one time. This brings many advantages and challenges as well, such as managing shared resources, thread safety, communication, and synchronization.
Go allows for lots of programmer control over data for maximum program efficiency. Many languages only have a few data types, however, Go allows for very specific control over bit size of data. Go supports booleans, integers, unsigned integers, strings, integers and unsigned integers 8-bit through 64-bit specified, complex 64-bit and complex 128-bit, as well as byte-sized data types and runes, which are an alias for 32-bit integers. In Go, there is only one loop construct, the for loop. It is similar to that of C languages and includes an initial statement, a condition, and a post statement. In our first example here, we have I set equal to 0, and then the condition is as long as I is less than 5, and I increments through each iteration. In our second example, because the for loop is the only loop construct, you can remove the initial and post statements, which acts as a while loop. The example depicts a while loop that iterates as long as I is less than 5. If statements work the same way that they do in most languages, except for a few additional features that have been added to improve conciseness. The first figure shows a basic if statement. However, as seen in the second code snippet, if statements may contain a short statement at the beginning.
Expressions represent a value. Expressions are also strongly typed in Go because it is a statically typed language, meaning variable types are checked early on to catch errors. The code itself is also easy to read and extremely efficient. Statements represent an operation. Unlike C++, Go uses very explicit statements. The var keyword and control flow statements like if and for all have very clear meaning. Like shown in the variable declaration below, var a int equals 2. Here below are some expression examples following the Go syntax.
Subprograms are a feature of concurrency within Go. Typically, it is very difficult to understand and implement. However, Go routines make understanding concurrency easy. Go routines are functions that operate on separate threads and can be ran separately from the main process. In the figure below, the main process extends fully from beginning to end of runtime, and the Go routines all run at the same time to aggregate data. For example, if you wanted to read from a database with 1,000 plus rows, the typical method for reading each row would be with a for loop iterating through each row. However, Go routines allow multiple loops to be ran on subgroups of the original database, which greatly improves the runtime efficiency of the program. Channels are a safe way for Go routines to communicate and coordinate with one another. Data can be safely sent and received between subprocesses. Wait groups are a synchronization primitive that wait for a series of Go routines to finish before proceeding with the primary process. This allows for multiple Go routines to run at one time and takes care of all synchronization between channels and memory behind the scenes. Mutual exclusions, also known as mutexes, provide help with synchronization between Go routines by ensuring that only one subprocess can access one resource at a time. This prevents data races and improves data security by ensuring that two processes don't try to access and alter the same data at one time. Mutexes are included in the standard library and have two methods, lock and unlock.
Unlike C++ or Java, Go is not entirely object-oriented. The primary difference is that there is no type hierarchy, meaning there is no inheritance or class system. Structs defines custom data types alike classes in other languages, but minus the inheritance. This is shown in the figure with type person struct. Methods define methods on types and structs by attaching a function to a type. Interfaces are essentially a workaround for inheritance. They define what a specific type can do without explicitly stating how to do it. This lets methods be called on different types as long as it follows the rules of the interface. Embedding allows embedding structs within other structs, which makes code more reusable.
Go is widely used for software programming, and in return, errors will become very common practice and need to be properly handled. They are different than exceptions. Errors are a type and can be created using an interface. Something with type error will be treated as an error. In the figure below, we are creating a new error, div0, and calling a function intdiv, which takes in two integers a and b, which also returns an integer as well as an error. If our divisor is 0, we will return our custom error since you cannot divide by 0, and it will print our error to the console. If the error is not equal to nil, it will perform the function as intended and will return the answer as well as a nil for the error value. For handling multiple error types, many other languages implement try-catch blocks for their error handling. The alternative for this in Go is as follows. Within the if block, one may implement a switch statement for what to do depending upon the error. In our example, if we are dividing by 0 in our function, we will return the div0 error, and if another error is found, this will be the default case of the switch statement, and we will output that error to the console to let the user know what the issue was. Go contains many rich features that greatly improve readability, writability, and overall user experience. In Go, variables are typically initialized using the syntax var I int equals 0, where we have var for the declaration, I as the variable name, int is the type, and 0 is the value that we are assigning. To improve user experience, variables can be defined with a shorthand assignment operator. The above statement can also be written as I semicolon equals 0.
Because Go has been a major player in the programming industry, the developers included many enhancing features to help with large-scale projects. One of Go's primary features is its built-in garbage collection. Garbage collection refers to the act of recycling memory by identifying parts of memory that are no longer needed for the program. Memory is a finite resource, which means it must be carefully handled and recycled to ensure that a program does not run out of memory. In Go, it is a syntax error to define and initialize a variable and not use it within your program. This problem prevents wasting memory, a precious resource in programming. and greatly reinforces habits that will make your code more readable and manageable.
Go Standard Library contains comprehensive resources for topics such as networking, file handling, cryptography, full-stack development, and much more. Within Go, all programs are housed within packages to organize source code. This helps prevent rewriting code. You can import packages from the standard library with no extra resources just by typing import followed by the name of the package you would like to import, surrounded in quotation marks. Some common packages included within the standard library when defining a main package include FMT or format, which includes basic input and output as well as string formatting, which is very similar to IOStream in C++. The math package contains basic constants and functions for mathematical purposes. Time allows for tracking and displaying time. OS allows for navigating the computer's operating system. And net is for basic networking needs such as TCP, UDP, IP, DNS, and socket manipulation. Strings is for basic string manipulation, and there are tons of other packages within the standard library that can also be imported, as well as other packages that can be downloaded from GitHub.
Go is very well documented and has lots of great resources for learning, practicing, and mastering the language. Some free resources used for this project include go.dev. The official Go website contains lots of information from tutorials, styling guidelines, a playground for testing code, and documentation for all functions included in the standards library.
Another resource is Go for Sizes, a collection of 20 projects for Go programmers to hone their skills. Each project has an assigned GitHub containing instructions and an example solution if you were to get stuck. Video tutorials are also provided. Finally, we used golangbook.com. The site houses 2 free ebooks containing all information needed for basic Go programming. Includes topics such as types, variables, functions, pointers, control structures, object orientation, packages, and many other topics discussed in this presentation. For our first tutorial, we will be teaching how to use Go for the first time in the terminal. First, to do this, we will navigate to the Go website and we'll download the current version of Go, which is 1.22.2. I already have it downloaded, so we can already go ahead and go to the command prompt. Here we will navigate to our home directory by CD, standing for change directory, and the slash just represents your home path. From here, we can go to your directory in which you would like your Go files to be housed. For mine, it will be in VS Code and then in Golang. From here, we can mkdir, which stands for make directory, and we will call ours 3370 for programming languages. After this, we can copy con test.go. This will create a file called test.go, and we can copy the contents. Now we will go to the notepad and we will write our program. So to do this, we will package main, which is necessary for all Go programs, and we will import FMT, the formatting package. Then we will define func main, and then brackets. We will FMT because that is the package where our print ln is coming from, capital P because it is a method in a package, and then there we will type our string hello world. We'll end it with the curly braces and include the quotation. We'll copy all of this, paste it into our PowerShell, and then Control Z to end our command, enter, and our file is copied. We can now go mod init. We'll give all the external dependencies needed to run our Go program. Finally, we can go run test.go. We have our output hello world. For our second tutorial, we will be teaching how to write a hello world program using an IDE. IDE, or Integrated Development Environments, are applications that house features for programming languages and act like a workspace. For this tutorial, we will be using Microsoft Visual Studio Code. First, we will navigate to Chrome and make sure that we have the current version of Go installed, 1.22.2, as well as Visual Studio Code installed for Windows 10 for my system. After this, we'll navigate to Visual Studio Code and ensure that on our extensions tab that we have the Go extension installed. Mine is already installed. Then from here, we will go to File, Open Folder, Local Disk, VS Code, Golang 3370, and select that folder. From here, we are in our 3370 folder, and we can make a new file. We'll call it again test.go. And then, same as before, we will package main, import fmt, func main, and then fmt.println, and then hello world. And then from here, we will go down here, open the terminal, same as before, we will go run test.go. I forgot we have to save our files. Files have to be saved, and we can go run test.go. We have our output. For a Medium program, we've chosen to implement a file renamer. It will read from a given directory, will lex the file path name for title, artist, etc., and will restructure the file's name to the given format. Then it will also maintain all existing directories. To do this, we have two functions. We just have rename file, which takes in a string file name and splits the string into slices, which are dynamic arrays to store portions of the original file name, then reorganize the pieces of the name to the desired output. Our main function will prompt the user for the base directory and will then walk the file path and retrieve all files from that directory. We will then retrieve the file's name and we'll call rename file on each file object. Let's look at this in VS Code. So here I'm in my Golang folder and I have my file renamer.go file. We are using the fmt, os, log, and strings packages from the standard library. Here we have in our main function, I'll just walk through this step by step. So dir is going to be our directory that we would like to use. So mine is in VS Code Golang file practice, just because I have a few songs set apart right here just to show. I've already performed this on the USB, but these were just to practice and to make sure everything worked beforehand. Then we are now using the OS package and the open method to call on our directory, which will return here an OS file type, which is our user dir, and this underscore represents our error, which we are not using for this because we know that it will work. And here we will use the user dir object and call read dir. This 0 just is for this and will return all of the records instead of just a specific number of them. And that will be written to files, which is a slice again, and error will be also returned. As long as the error is not nil, we will log a fatal error and will return the error here in this %s. Then for each file in the range of files is what this statement says. For each file in the range of files, as long as file is not a directory, we will save the name as the file object's name, and then renamed will call rename file on that name and will be a string, and then we will then print that string. Just because we are not actually renaming these files for practice purposes, this function here would rename them. However, I would not like to do that in this instance. We can go down here to our rename file function, and it takes in a file name string and returns a string. We have pieces is our slice that will split file name at a period. So for example, if this is our song, it will split it at the first period that it finds, and will save for the first element in our pieces array will be all of this. The second one will be MP3, so we want the last thing in pieces will be saved as our extension, and then the remaining thing, excluding the extension, will be saved as no extension for us to work on next. Then we will do the same thing. We will split it at DJR because all of our files have DJR at the end, and this will save the DJ name. And then no DJ will be, again, the slice minus what we just took out. And finally, we have the frequency range, which will split at the first open parenthesis and will read until it is done. It will save the frequencies, and then song name is just whatever's left over since we've been taking out each step before. Here I would prefer angled brackets over curly brackets, so I use the strings package to replace all instances of curly brackets with angled brackets in our frequency string. And then finally, at the bottom, our new name is a new variable using the shorthand assignment operator. That is the frequency plus the song name, a space, the DJ name, a period, plus our extension. And we will return our new name, which will go up here because it is our rename file. And finally, just to see that this works, we can go here to our terminal and we can go run file renamer.go. And we see that we have our angled brackets and frequencies at the beginning, as opposed to up here in our final practice folder, where we had the song name followed by the curly braces or curly parentheses, and then the frequency range. So we saw that everything worked out correctly.